better. Okay, good afternoon, everyone. This is not my normal type of presentation. I actually volunteered to do this on behalf of Flavio Luciani, who's the CTO of Namex. Well, we originally tried to persuade Flavio to come here. Small issue is that Namex have their annual meeting Wednesday, Thursday this week. So it's kind of a bit difficult to get back and forth to come to the Beacon Experience Forum. So this is work that Flavio has been doing over the last few months with the support of John Suter. Some of you may remember John. He was the past CEO of Lynx in London for many years until he retired. And so they've been working on this, I don't know, probably since I would say probably middle of last year, and I've provided a little bit of help to them just for some of the Asia-Pacific content in this. So I'm not going to pretend I know everything in depth, but I thought I'd at least try and give you a little bit of visibility, more so that John and, well, Flavio and John can get some feedback based on what they've been doing. Get more insights. I mean, I suppose the content of Flavio's paper for this part of the world is probably a little bit thinner than it could be, probably because I didn't give them enough feedback when they actually wanted it. So, but I mean, the fundamental is that there's this growing narrative that we don't need peering anymore. The whole internet's hyperscalers. You just connect to them and everybody is happy. So is this really the case? So they were heading off. Okay, obviously two folks from major exchange points in Europe heading off trying to see if this is really true or not. And you know, the black line just shows the the general growth in the number of internet exchange points worldwide. So it still looks like onwards and upwards with not really too many blemishes happening in that. But what's interesting, I don't think the pointer works, but the yellow line shows that Europe is leveling off. And is this a good or a bad thing, or can you imply anything from that? I would say probably not, because Europe geographically is quite small, and it's fairly dense, and well, there are only so many exchange points you can have. Whereas other parts of the world, for example, here in Asia-Pacific region, every country still has a lot of opportunity for interconnects, kind of what we're talking about this morning. And of course, there's also a lot more folks who are offering various types of remote peering, for however you want to define remote peering. I mean, is it really just the new tier 1 transit provider, which is kind of my personal point of view, or is it something else? So this perception that peering is dying comes from several observations. Slower growth in some large and mature hubs. Well, of course, you know, if a large hub is well established, it's not really going to grow much more. Stabilization of traditional indicators such as membership and capacity. There's an increasing use of PNI, so that's a private network interconnect, where you do the physical wire between you and your peer, rather than going through the IX fabric. And greater visibility of alternative interconnection models as well. You know, we hear of the megaports and so on of the world offering other ways of doing interconnects. So you see these kind of, over here you see the graph heads onwards and upwards, but probably in the last year or so, there's clearly a tailing off in that particular growth. So what really is going on? So is it the beginning of a structural decline or a new phase of the evolution of internet connection? You know, when we were planning the panel discussion this morning, we were then kind of, well, do we need to do this presentation first? But then maybe doing this presentation after the panel discussion might be more enlightening, or I've no idea. So it kind of loops back into what we were talking about this morning. You know, what's really happening with internet exchange points? Do IXPs make the internet faster? what's the perception of faster, what does faster mean? And if people are looking for faster things, do they go to IXPs for that? Or they're going directly to the hyperscalers, or I don't know. Or as the graphic has here, I mean, this research was spurred by one presentation. I don't remember, I think it was at a RIPE meeting where one of the, well, it wasn't a sponsor presentation, but one of the presenters was saying that, well, you know, they've got a new service they're trying to offer, much better here. Look, IXPs aren't getting any more members. Come connect to us. We've got all this wonderful stuff that you can have. Hence, I don't know where Flavio got the graphic from, but the graphic explaining this. And so this is the paper that Flavio's been working on. I don't know if this is version 2. I just noticed February 2028, which is a while away yet. So maybe that's the second draft once you have provided feedback to Flavio and John. But the core thesis of the paper is the market is not declining. It is undergoing structural transformation. Traffic is still growing, but our traditional ways of looking at it really aren't quite enough. So counting number of AS numbers, counting number of members, looking at the port capacity doesn't really fully document what's going on. Of course, slowdowns in mature exchange points, we know that that's happening. There's only so big you can get. And you know, Romain's slide this morning showed the mature exchange points versus the ones that are still growing. The local ones are still growing quickly. The well-established ones have kind of reached where they're going to get. You know, this is the IXBR traffic. I mean, you still see the onwards and upwards. The M6 traffic is, well, it's kind of pretty stable about where it is. And also, well, these are the hyperscalers. The general peering policies, originally the big content providers would turn up at an exchange point and they would peer with anybody. So open peering means they peer with a route server. They're withdrawing from the route servers. They're now doing bilateral peering, and some of them are even withdrawing from some of the exchange points. And you know, a lot of that discussion is, well, we have so much capacity, putting it through an IX doesn't scale well. We have to put it directly over direct links to who is drawing this. So you see these changes in the peering policies for some of them. And you know, admit, route views were the same. We used to have an open peering policy. Now it is selective because we're getting a lot of small networks who are giving us 5 routes. Not interesting. We want to get the networks that are going to give us the full BGP table. So we're getting a lot more selective, like content providers are as well. What's this showing? Growth of PNIs in network caching. So what happened here? Google stopped peering with route servers at, this was, I think this was Namex? I don't know, wherever it was. So they stopped peering with route servers, and so there's that drop in traffic. But you still see the traffic is creeping onwards and upwards, simply because, you know, one entity has moved on. Oh, sorry, no, this is CADA snapshots, that's what it was. So this is the change. So, and then Flavio's included the fact that, you know, the Google announcement, no longer using the route servers at Namex from May 2024, that was. Also, the growth of PNIs, other network caching models. So this one, so Google, just again, looking at the peering DB entries, a lot of this comes from peering DB, a lot of it from the CADA snapshots also. Number of exchange points Google was present at. This was back in July 2024 versus March 2026. So a couple of months back. So it's dropping, and sure enough, it is dropping down. And you know, those of you who are watching it will have seen that, well, the activity is taking place, and we mentioned it on the panel this morning as well. But that was there. So a couple of European exchanges, but what about the rest? I mean, one interesting thing from my perspective, being at route views, you can see all the new members coming at all the different exchange points, increasing ports and so forth, and we see a lot of the hyperscalers increasing port capacities at some of the exchange points. So here are examples: Amazon, Meta, Microsoft, Akamai, onwards and upwards. There's no real obvious change in any of these. I don't know if the gaps, yeah, the gaps in the graphing. Structural changes in traffic, so the traffic concentration has changed. There's higher traffic per network, reduced marginal contribution, so smaller networks have less impact to the overall traffic growth, and alternative connection paths as well. A lot of it through PNIs and other architectures. But public peering remains essential. It still continues to provide the most effective way of interconnecting a broad ecosystem of networks. I mean, again, from referring to this morning, we talked about keeping local traffic local. We couldn't even decide what local traffic was, because what might be local could be hosted in a hyperscaler, and it may no longer be local, even though it's local content. So public peering is still the most efficient way of interconnecting operators who need to exchange content, traffic. PNIs are being used more and more for high volume. Would you run 1 terabit through a link through an exchange point, or would you run it on a direct fiber link between directly to the other operator? You know, that sort of volume, losing that volume because a switch has stopped working or a fiber patch has failed, has fairly big impact. In-network caching is growing. More and more operators have caches within the network. That changes the picture as well. And of course, the edge architecture is changing also. So if we look at the mature versus emerging markets, Europe definitely slowing down, big time. It shows stability. It doesn't show a decrease, right? It shows it pretty much has reached the peak of where it's going to get. And so that was in the UK over the last, well, let's say 2, 3, 4 years. The membership and the capacity connected. So the capacity you pick out from the peering DB entries, the capacity is pretty much been stable over the last 4 years. Whereas this Netherlands, a similar picture. We plateaued in about 2024. Not a lot has really changed after that. This one, Germany, same story, plateaued again. Whereas if you go, where is this? This is in Kenya. If you look at the exchange points there, there's no real obvious sign of any type of plateau. I mean, when I started off, really, well, the start of this century, Africa's interconnect was in Europe. A lot of the European countries, European exchanges was the interconnect. As we get more exchange points being built on the continent itself, you see more and more local interconnection, which is great to see. So this is Kenya, Nigeria. Again, the growth is significant. Philippines, onwards and upwards. Also, there's not really a lot of change there. Indonesia, well, I mean, Michael's going to be talking about some of the interesting things in Indonesia in a bit. Onwards and upwards within Indonesia as well. Japan. Japan is starting to show the plateauing of capacity, but membership is still onwards and upwards as well, as our friends from Japan can probably share with us. Where's this? Mexico. I think you get the point. It's a lot of these places. I have no idea what happened in Colombia in 2024, but somebody obviously ran away with a lot of gigabits per second. What else? Peru. Still, anyway. So simply because somebody turns up in Europe or is in Europe and sees that not a lot is changing, doesn't really mean that the rest of the world isn't seeing any change as well. And even from North America perspective, at least some of my views in there, I see plateaus in some places, but some of the smaller exchanges, the growing exchanges in other areas are still growing as well. But from our part of the world, I still see this big growth in membership and interconnection. What makes an exchange point successful? Telecom market liberalization. I'm from the UK. I went through the whole European telecom market liberalization. I was part of the early days of when Lynx was established in 1994. I know the difference that simply liberating the market there made. And I've watched over the years as other countries have done the same thing, where they allow network operators to interconnect without licenses and laws and goodness knows what else. Helped create that internet exchange point, helped create the interconnects, helped create local problem. We mentioned the panel this morning about chicken and egg, right? We can't have local content until we have an exchange point. We can't have an exchange point until we have local content. So countries with community-based exchanges have worked with that, formed the interconnect. There may be no traffic, but that will appeal to content operators start locating content locally. So local content, eyeballs, domestic demand is the main driver of growth. Thailand has unique language, not really spoken anywhere else in the world outside Thailand and Laos. And the other countries in a similar situation, unique language, fairly unique culture, so there's a lot of local interest. Population scale and the data center ecosystems as well. Exchange points and neutral data centers evolve very closely together. What do I have left? Right. So what else is important from this talk? So exchange points are evolving into broader interconnection ecosystems. You can see that. Again, back to the discussion of what a local regional exchange point is versus an international. International is a lot more about how to get people more into an ecosystem. There's a hub and spoke model where we're moving from linear supply chain to a distributed architecture. And exchange points are no longer just about ISPs. A lot of other industries are coming. I know that myself from all the BGP workshops I'm still doing. The participants there are not ISPs, or very few ISPs. We see a lot of banks turning up, so the financial industry. Government is turning up, so a lot of public service is turning up. More universities, independent of the research and education networks. A lot of other entities involved in just general infrastructure are now taking part in exchange points. They're coming, they're learning BGP, they no longer outsource it to some tech company that doesn't know what they're doing. They're learning BGP themselves, joining internet exchange points. APNIC will know the same thing from the membership and who's getting resources and so forth. So it's a very, very big change. And the final one there is the service diversification. Demand is growing for security, resilience, advanced interconnection services. So there's this ecosystem. This is looking at peering DB. The orange here is the number of new actors. I don't know over what time frame, but probably over the last couple of years. New participants compared with the traditional networks. And then, of course, resilience. Traffic localization means you don't depend on international connectivity. People wonder where their data is. Last 3-4 years, I hear data sovereignty talked about an awful lot. Why put my data in a hyperscaler? I don't know where it is. I don't know whose jurisdiction it is in. I don't know who's spying on it. How will the internet work if my external links are down? You know, these days you walk into a cafe or a restaurant, it's a QR code you scan which opens a website on a data center that's somewhere else in the world. What happens if all that stops working? How do I pay for my coffee? If the payment system is using international connectivity, can you turn off your internet in your country and everything still works? I shouldn't be asking that question. I was horrified at that question in the 90s because we were building an internet for everyone to use everywhere. But we now have to ask that question, will all this stuff work? And unfortunately, or fortunately, this makes an internet exchange point even more important because that's the only way you get the networks in any country to interconnect. So there's the whole data sovereignty thing, it's, you know, and the cloud-only strategy. 10 years ago, everything in the cloud. Nowadays, you think long and hard before you put anything in the cloud. Long and hard. I was at, NSRC did a virtualization workshop at KU, Kasetsart University, last week. Why? How to build a cluster. Not how to build a cloud, how to build a local virtualization cluster using Proxmox. Why? Why can't we just throw it in the cloud somewhere? So, future of peering. Well, edge, ultra low latency. Paresh talked about AI. Internet of Things kind of sort of disappeared from the public eye. It's now AI. Everything has to be AI. Apart from all the hype, we still have an infrastructure to deliver to support this. A lot of people building AI data centers need crazy, crazy bandwidths and crazy latencies and crazy everything else. What's called here micro internet exchange points. More local and regional exchange points will emerge. I still think, FTAB was hinting at that this morning, every single place does need an IX. And it doesn't mean a country needs, place, locality, whatever that locality means. And finally, geopolitical relevance. Interconnection is really becoming very, very strategic. Right, so conclusion, peering is transforming, it's not declining. We're not just dumping everything to the hyperscalers, as some people are saying. Local and regional ecosystems are coming more and more important. I've watched BPF2026 Peering Forum over the last 10 years. The first one, few people turned up, and now we're, 460 have signed up to come to this one. It's incredible. Over that 10 years, you see the importance of this event. Just as many people are in here as there are outside talking and discussing and peering. IXPs are strategic infrastructure. Some IXPs are already considered as national infrastructure, right? They're as a critical infrastructure for the nation. I know I've been trying to say that 20 years ago, but they are now seriously being considered as critical infrastructure for the nation. And that has big implications as well for the people operating it, the standards, where it's located, and everything else. Resilience, security, sovereignty as key drivers. Where's your data? How does it keep running? The screen's telling me my time is up, but this is the last slide. Growth will continue globally. Places will plateau once they're really saturated. So I hope this helps. Flavio and John would love to get feedback. So this is really the first go at this paper, this presentation that comes with it. They would love to get your feedback. They've done blogs. They've done a blog for APNIC, Ripe Labs, there's one, and I think there's one for LACNIC and Aaron as well. So we'd love your feedback. Please don't ask me any questions. Please don't, well, you can give me feedback that I can pass on, but I'm sure you can talk to Flavio and John directly. Thank you very much.
Thank you very much, Philip, for sharing these valuable insights into the industry, which continues to change rapidly, even sometimes testing and challenging our routing ecosystems. And Philip will have a present for you too, but just before the break, okay? We'll give it to you just before the break. And speaking about routing challenges, let's continue with our next session titled Routing at Scale, Challenges in Indonesia's Multi-IXP Ecosystem. This session explores the operational and routing challenges that come with a rapidly growing and highly distributed internet environment, and also lays the framework for how routing efficiency may be improved. Please join me in welcoming Michael Takeuchi, Chief Technology and Operating Officer at RAPIDNET and Deputy Chief for Indonesia Internet Exchange. Michael, welcome to the stage.
Hi. Okay. Hi everyone. This is I already presented this topic before in some of the other NOC event as well, and the RAPIDNET as well. But I hope that I can present again here and can discuss more about how the tie networks, and we can discuss the problem that we have, and also how we can solve the problem together. So first of all, let me introduce myself. I'm Michael. I'm working for an ISP called RAPIDNET. I'm also part of the IIX. It's also one of the largest internet exchange in Indonesia. Yeah, I'm based in Jakarta, but I like to travel. Uh, I like Bangkok as well, especially the food. Well, talking about the IX in Indonesia, 20 years ago, we only have two exchanges, which is IIX and also Open-IXP. But now we have so many internet exchange. So start from 97, IIX was built. It's 29 years ago, and we have the historical of the traffic. 26 years ago, it's only 3 Mbps. But now I believe 3 Mbps only belongs to one single device. Maybe more. I believe we do the download, we do the live streaming, and maybe you have some background traffic that you cannot see, extracting your data or something. Yeah, it's gonna be more complicated now. But yeah, 26 years ago, it was the peak traffic of the local Indonesian internet is. And 2005, we have another internet exchange called the Open-IXP, because during that time, actually until now, IIX is belongs to the association, to the ISP association, so it's exclusively for the association member. And after that, we have Open-IXP, which is open for every kind of networks. And I look back 2026, now we have more than 15 IXP, different IXP in Jakarta. And if I check in the PeriDB, it's more than 60 across Indonesia. But yeah, I believe many of the IXP there is dormant. It's not that huge, but yeah, it's still so many IXP. And more than 1,400 different ISP, and also more than 4,000 non-ISP. So in total, it's more than 5,000 ES number in Indonesia, which is, I think it's quite a lot. And yeah, when we do the traffic engineering, when we try to solve some kind of problem, access problem or something, application problem, is make more headache for us. Well, I take an example. This is my ISP. Yeah, maybe it's like a little bit more appearing personal. Now, yeah, this is my ISP. For myself, I have my big POP in Jakarta. And as what I mentioned before, we have more than 15 different ISP in Jakarta. And I connect with 12 different ISP only in Jakarta, excluding the other city, let's say the other big city like Bandung, Surabaya, and maybe Bali. Yeah, I think the famous one is Bali comparing to the others. I connect with 12 different IXP, and which is I have around 12 different paths for going to the single networks. Yeah, it's so many challenges. Oops. Can you guess how many peer that I have in my router? Anyone? No, I don't have any any giveaway, but yeah, I have more than I almost have 400 peer in single router, and it's only the router that handle the domestic traffic. Is excluded with the IP transit, is excluded with the other exchange, overseas exchange, is only the domestic router. So let's say I have my bilateral peering with some kind of the CDN provider. I do the bilateral peering, and I do the peering in a 12 different IXP. So if I have 5 different bilateral peering with, 5 different CDN, so 5 times 12, It's around 60 peer, and some of them have more than one peer. As a redundancy, they usually have two peer, so it will double up, becoming 120 peer, only to 5 CDN provider. I'm not calculating the others yet. And yeah, I need to make the policy to filter and maintain the routing as well. Yeah, this is the example. I receive one single prefix here, but from 11 BGP session. So yeah, as we know, usually the IXP will have 2 different route server as a active and active as a redundancy. But yeah, from 5 different IXP, we got from 11 BGP session. But it's only single /24. Can you imagine if we have /22? And then, okay, you're not only receiving the /22, you will also have the /23, and you also have 4/24, which is 4 plus 2 plus 1, which is you will receive a 7 prefix for single /22 from 11 BGP session. And yeah, also not only talking about the complexity, some suboptimal pathing also happen, because as we know, the BGP is not working based on only the ESPAT. Yeah, ESPAT is one of the BGP metrics, but many of provider also using the local preference, and yeah, it's gonna be more complicated if doing the BGP prepan is not enough, so we need to check to doing the looking glass, how the perspective from the others networks. And yeah, this is my case from Jakarta going to Singapore first. Even in Singapore, I'm not going to the IXS in Singapore. They're going to the transit provider, and then going back again to Jakarta, and then I reach the destination. Yeah, the latency issue is increasing, that, and maybe in some customer that have the latency sensitivity, it will they will complain about it. But actually, this is still good. I have another problem. It's increasing more than 200 milliseconds, because from Singapore it's going to Amsterdam, and then from Amsterdam going back to Marseille before going back to Singapore. So maybe you can tolerate the 10 or 20 millisecond, but I think increasing more than 200 milliseconds is intolerable. And yeah, it's a problem if you connect, maybe you have so many peer, so you need to maintain the period and the routing correctly. And yeah, sometimes we have the lack of visibility. Some networks have the looking glass. It's good if you have the looking glass. Or maybe some of them doesn't have any basic telemetry. You cannot see the MRTG. They don't have the looking glass. No traffic stats, even no point of contact. Maybe even they have the point of contact, they have the email. After we send the email, okay, they will reply in the next month. It's also a problem. And yeah, sometimes the network engineer, we are a magician, because we don't know what happened, and it's solved and recovered by itself. Yeah, sometimes the problem maybe is happen in the other side, the backbone issue, the congestion issue, the backbone failure. But yeah, if we don't have the visibility, we don't have the right contact to, yeah, it's gonna be the big problem. Yeah, we are a magician consultant. Yeah, this is one of the case study that I had because of the lack of visibility. So there is a new IXS in Indonesia. They don't have the MRTG to be shared with the peering member. Yeah, we can ask the IX operator, but they don't have it's not published directly to the member. So the problem is I have 100G port to the IX to some the new IX. I have the 100G port, but the problem is the other peering member they only have 10G port. They are thinking that oh, this is a new IX, no one here, no content here, so they are just connect with the small port with only the 10G port. So when my traffic is swing from other, let's say the new, I mean the old IX, I mean the other IX that already established so long, maybe the traffic is swing to the new IX. The traffic is congested, but I don't know where the traffic congestion is, because if we see the graph, it's only 6 gigabits, but I'm using 100G. So how to trace this kind of problem? Maybe we can see the packet loss even if we monitor the IP, but also we need to check the routing path. Probably they will going through this IX, and the inbound and the outbound is going to the different path. So it's going to be another problem. Yeah, so my port is not congested, but the others is congested, and we don't know where is the congestion happen. And yeah, what I see now, there is no common standard. It's IXP, they have their own policy, the platform is different, and the community tagging is also different. So sometimes we need to ask first, there is any BGP community guideline or something, and also have a different peering policy. Yeah, this is the one of the no common problem, the case study that I had in Indonesia. So there is one IXP, they didn't support with the BGP community. So we cannot do the selective advertisement, so we cannot reject our prefix to the specific peering member. But the problem is the peering member that we saw here, they have the 50G of port, but the problem is the port is congested. As we can see here, the graph is flat, and yeah, you know, the only way to solve it by rejecting our prefix there. Well, yeah, it's not easy, because if we're rejecting totally to the route server, then we're gonna loss of the other peering member as well. Well, actually, we are not completely no common standard. We also have manners that's already here. So what manners bring is they are bringing the security baseline, the route server filtering, do some kind of the routing safety, and also they encourage us to share the contact information and the documentation as well. It is help, of course, it's help, but from my perspective, we need to have more be like an operational approach, because as what in my opinion, manners is more like a security approach. We need more the operational approach, not only the security. Of course, security is also important. It's also the foundation of all the things that we had, but we need also to discuss about how we can operate this kind of feature, the technology. Yeah, it's giving us a strong baseline, but the problem is in daily operation, some inconsistency still happen, and the non-technical factor like commercial factor or some factor that I cannot mention here is slow us down. So yeah, I'm happy to discuss about it. Oh yeah, the other problem is routing upload. I just also mentioned about it before. We have single /22 and divide by the /24 and /23 is only, yeah, make your routing table loading. Can you guess how much routing table that I have in my domestic router? Can you guess? I'm saying that maybe the forwarding information base, which is the active route, 10,000, 20, you guess, 5,000, 5,000. Can you guess the others? How about in Thai? In yeah, the domestic routes, 20, 20,000, 20 to 30,000. Okay, I have 38,000 active route from almost 300,000 prefix. As what I said, I got single prefix from 5 different ISP. So 38,000 times 5 or maybe more. So the active route is around 38,000. And the others, the route that not active as a backup or something is around 286,000, almost 300,000 of prefix. I mean, even the global prefix is around 1 billion, no, 1 million, I think. Yeah, around 1 million. So it's around almost 30% of the global routing table. But it's only the domestic prefix. Then, what we can do? That's the question. Well, in some technical perspective, we can do some internal control. We can check our routing policy. We can build the redundancy, and also deploying the monitoring, like using a good telemetry to see how is the traffic going. We can deploy the net flow, and we also can plan doing the capacity planning, not only do the reaction to the problem, but we need to have a planning how our networks will be going in the next year, in the next 2 years, or maybe even the next 5 years. Because yeah, as we know and as we can see the growth, especially under this kind of AI things or something like that, the traffic growth is really huge now, and we need to also stand aligned with the global standards, follow the community, see the RFC, and also actively engage to the community like this. Is it enough? Sometimes I can say it's enough as a fundamental, but I don't think so, because collaboration and communication is also pretty much important as well. Because even we do good in the technical things, but in the non-technical things like the negotiation, doing a peering agreement, it can be bad as well. But yeah, so it's pretty important to collaborate and how we can achieve the good quality. We can give a best service to the customer as well. Yeah, it's about the not only about the technical things. It's about the communication and coordination. So I would like to say thank you as well to the committee that organizing this peering forum, because without the peering forum, we cannot see each other, we cannot talk, we cannot share, we cannot coordinate directly in person. Because yeah, talking in person and talking in email is gonna be totally different. Because in person we can have a beer as well. Well, I think my time is almost done. We have 2 minutes left. But so my conclusion is, whatever remains unresolved, we're gonna resolve it at the dining table. Thank you so much.